Okay, guys, before we get going, let's go through the screenshot routine. You see up the top there? That's our letterhead, right? Those are the breadcrumbs. If you want to get a hold of me, right, let's do a screenshot, okay? Now, let me move on here. Hang on, I'm going to move this so you can see it. All right. But Tangent Engineering has sold many lathe OD burnishing tools. A tool that you can burnish on the OD using your lathe. All right? Lathe OD burnishing is not common practice. Right? Now that you have one, do you know how to use it? Right? Big question. Here's another question. If I gave you a jet plane, could you fly it? Alright? The goal of this video is to get you to use it. I can get you there by providing a useful chart. Alright? A chart that eliminates all the cumbersome math. I've converted the cumbersome math into lathe language. The burnishing tool with a chart allows you to quickly get set up in minutes, right? From your toolbox to the lathe in minutes, the following visuals will show you how we develop the chart. All right, I'm showing you some of the cumbersome math that you're going to avoid. You see this? You got to start out with circumference. Now, whatever formula you use, circumference equals pi d, blah, 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 right? It tells you in one revolution, at circumference, see that 750? That's a 3/4 inch diameter, right? One revolution equals 2.356 inches per revolution. You don't want to screw around with this, right? And at 439 revs, you got 1,036 inches per minute. That's for a 3/4 diameter. Now look at all the math I've done. I've done the 1 inch, right? Because obviously the circumference is different. I've done 1.25 inches, right? Circumference is different. I've done 1.5 inches. 1 3/4, will go all the way down to 3 inches, right? The circumference at 3 inches is 9.42 inches per revolution. The other end, it's on the small end, 2.356 inches per revolution. You want to screw around with this kind of shit. You want to get that, you don't want to do all of that, all right? So I'm going to show you how to eliminate a bunch of that. Hang on, right? Let me show you what's going on here. Then I'll show you the chart. Hang on. All right. I've been working with Doug Perfetti, who has a chart and has created what I'm going to show you. And I'll show you all the vital information it took to get the visual you see here. Alright? So bear with me. You see this? First of all, dead center of the shaft, that's 12L14. The feed rate he used per revolution is 4,000. See what a mouse is? So he turned this diameter, see the turn diameter where the mouse is? He turned it to 1 inch on the money. Right? Right? Then he burnished at a higher rate of speed. See down here where the mouse is? It says turning 330 RPM, burnishing 510. The difference in diameter was 1,000. See it here? So he did it in 2 passes. You see all this information for 12L14? It's exactly the same information for brass, which is C-360. Same speeds, 2 passes. The only difference here is we're showing here, we're showing a minus 2/10 burnishing. You see it? That's exactly how it looks, right? Guess what? It's 1018. Everything's the same except the difference here. It's 1 and 3/10,000, right? Still 2 passes. So he's used the same for all of them. I made my chart relative to that. Alright? So let me show you this. Alright? See, it says up here, turning and burnishing chart. Feed rate per revolution. That's top left column. See, they're all 4,000s, every one of them. Finish turning, these 2 columns. The shaft diameter, 3/4 or 750. The RPMs he used to turn it with 439. To burnish, he burnished at 680 RPMs. You see that there? And here's the chart. The chart goes from 3/4 of an inch to 3 inches. We figure that's enough of that shit. Alright? Now we get below that, it says burning diameter difference. Steel. See that? These 2 are steel. That's all we got at the moment. The difference is for 12L14 minus 1,000. 1018 minus 0013. 1 and 3/10 of 1,000. For brass, you see it here, minus 2/10 of 1,000. That's basically what we're talking about, right? What do you think? So I developed this chart. I think it's doable, right? I'd like to have a couple of comments here to see if you can deal with this. What I would do is put this chart right here. See this chart right here where the mouse is on the left? Make that chart available, right? So that you guys have something to refer to if you understand the chart. We haven't done aluminum or stainless steel yet, but we're going to plug those in using the same feed rate and turning rates. Everything's going to be the same. All right? Hang on. So I'd like you to know, if you want, I can provide this. If you don't want, well, let me ask you this, and I'll say it again. If I gave you a jet plane, could you fly it? Once you got this thing, you want to go from the toolbox to the lathe quickly. You don't want to screw around with all this ridiculous math, all right?